In this video, we're going to be solving for the runway length needed for an airplane to take off, and then also develop some graphs of what that looks like for the position versus time graph, velocity versus time graph, and acceleration versus time graph. So the takeoff speed of our plane is going to be about 82.26 meters per second. And that's going to take the plane about 40 seconds to reach that takeoff speed. And then we can safely assume that the plane is going to start at rest as well and have a VI of 0 meters per second. Now we have a few different formulas we can use. We're going to take a look at all of our accelerated motion kinematic formulas, which are going to include these. Now with those three formulas, we are going to want to solve for the delta x. That's going to be our minimum runway length needed to have our plane take off at 82.26 meters per second. Now, in order to find delta x, we're going to have to use either this formula over here or this one right here. Obviously, this one over here does not have a delta x. Now, if we're taking a look at this one, we have the initial velocity, which is basically going to cancel out this beginning portion. And then we need a and t, but we don't have a, so we can't use that formula. If we take a look at the last one, we do have the final velocity, the initial velocity, and again, we don't have the acceleration, which means that if we have two formulas that we need, and both of which we can't use the acceleration needed to solve for the delta x, then we want to solve for the acceleration first. So we're going to go ahead and take a look at this first formula over here and solve for acceleration first so we can proceed with finding delta x. So let's go ahead and do that. All right, so we found our acceleration of 2.06 meters per second squared. Now, just based on your preference, you could use either one of these formulas to find your delta x, because this one is already rearranged to solve for delta x already. And I know I don't have to do any algebra. I'm going to go ahead and use this formula, plug in everything I have, and that should give me my delta x, which is my runway length. So after plugging everything in, because my VI is 0, this front part drops off, and then I take 1/2 times the A times the T squared, and that gives us a runway length of 1,648 meters. Now, if we were to create some graphs for that, we can do a position versus time graph, a velocity versus time graph, and an acceleration versus time graph as well. Now, if we want to draw either of these or any of these, we need to know a little bit about kinematic curves and then also use some of the values involved as well. Now, if something is speeding up, then on the position versus time graph, we're going to assume that this direction is the positive direction. So we're going to be rising up on the graph, and our slope is going to be getting progressively steeper because the velocity, the rate at which the position is changing, is increasing, because so the slope is getting steeper. So it's going to start at 0 meters, and then it's going to end at 1,648 meters, because that's where our runway ended before it took flight. Now, as for the velocity, if it is just increasing with a constant acceleration, then it has a constant increase and the same slope. And then it's going to start at rest, 0 meters per second, and then reach a final velocity of 82.26 meters per second. Now, as for the acceleration is the rate that the velocity is increasing. And remember, the rate that it's increasing is the same because it has the same slope. And our acceleration is 2.06 meters per second squared. So it's actually going to be a constant positive acceleration right at 2.06 meters per second squared. And that would complete our three kinematic graphs. So when you're solving for a runway length problem like this, or any kind of kinematic problem that involves acceleration, You always want to have three known variables. In this case, we are missing one of the variables that we wanted, so we had to make it a two-step problem and solve for the acceleration first. And then from there, we had options to use this formula over here to find delta x, or to use the second one, both of which would give us the same answer. And we got 1,648 meters. Now, when developing the different graphs, you want to make sure you're aware of how to create that curve. And then from there, use the values in the problem to properly label the magnitude of your different positions, velocities, and accelerations. So I hope that was helpful to you. Thank you for watching and listening.